OWSD, Organization for Women in Science for the Developing World, University of Harcourt branch. We've been doing this program for a while now, and you can see that this is the third time we're doing it. We did one in 2021, 2024, now 2025. Why are we always doing this? Those that we disturb all the time to give us money or to sponsor us, we just want to tell you why we do what we do. So we're encouraging girls to embrace STEM fields. It's not a new thing. It's not a new story. We hear about this all the time. STEM fields. Just look at this picture. Today is the International Women's Day, 8th of March, that started in 1911. It's not today, it has gone in a number of years. Look at this picture. You can see there's a hand, an invisible hand, helping the man, while the woman is the one pushing it herself. All women here, please clap for yourself. Because some of us that are Christians, when we pray at times, we thank God for that invisible hand that is doing miracles for us that we don't see. But men have that, women don't. And that is why we do what we're doing. We want girls to be conscious in their environment and know that they need to work harder, extra harder, to be able to make it. The decisions you make today will determine what you become tomorrow. So the International Women's Day, majorly, is for all of us here who care about women's equality, celebrate women's achievements, raise awareness about discrimination, and take action to forge gender parity. Now let's look at it. Imagine a gender equal world. Is it possible? I spoke with one of my colleagues the other day. He told me equality is possible, equity not possible. I didn't get what he was saying. But I feel all of us inside this room, both the male and female, we know that equality, equity, whatever it is possible. Abi? Yes. So a world full of bias, stereotypes, and discriminations. A world that is diverse, equitable, and inclusive. Everybody. There will not be any hidden hand helping the other person and not helping this other one. A world where difference is valued and celebrated. Nobody feels because you're a female, you can't make it. Immediately you're giving birth to, you're a female. Some people will bring down their face because they feel, because you're a female, there are places you can't go to. There are things you can't attain. But we're breaking that barrier, and that's why we're doing what we're doing. So let's accelerate this action, really. Let's walk the talk. Year on, the International Women's Day is certainly a powerful movement. You have heard when it started, so it's not a today thing, and I'm sure the men here, they've been hearing this thing for a very long time. So let's make a difference, think globally and act locally. Let's think globally and act locally. It's very important. I was just telling the day Professor Adeshope did the opening of this program we just mentioned, the gender equality policy program. We were doing a panel of, we had panel discussion. I just remembered what I didn't say that day. And I want to say it now because he's here. In my village, which is my husband's village, which is my village now, we do attend what we call conference every year, every December. And we have some set of people on the high table like this. Every other human being part of that community will all be here. For the past 16, 17 years I've been married. Anytime we go for that program, the only set of people here are all men. Both the IPP, the President PP, the President General, whatever they call them, the Treasurer, they are all men. And the women will be one side. The decisions will be taken here. The women will raise their hand, they will be saying this, that. Is it not what is fast here that will work, isn't it? So why can't women be part of this panel? So that is what we are looking at, a situation whereby the environment, our localities, our communities, our families, we start seeing the female, the girl child, the woman as part of this society. So we have to say there is space and place for everyone. We never fight this fight. It's not only women, and I'm happy that some men, like associating with us. That's the spirit of abundance. And so I just want to take you through memory lane. We started this program in 2021, and you can see that picture on my right. The former OWSD president, Professor Ikeya, she's the one that started this program. She's the one that thought about it. Because OWSD Unicord branch, we started in 2019. There was no program like this. So in 2021, she thought about it that these are the ones that will make the change. We have already made our decisions. We're already in the fields where we are. But the young ones, those in JS 1, JS 2, SS, they are the ones that will make that particular change we're looking for. So you can see, I'm the one trying to screw a robot there. So we're all in it together. So 2024, which was last year, we did something like this, and we also invited some of these schools, and that was the grand finale where some of our partners gave us some gifts that we gave out. And now we're in 2025. So we'll see how today will go, because these children have a lot to show us that we have learned so far. So STEM is the major thing we're talking about, looking at this particular Tech Girls Bootcamp. In as much as International Women's Day is talking about women in general, but our main aim is to help through STEM to make our young girls know that STEM fields are not difficult. They're not for men alone. Women can do it. And we are being underrepresented in most of these STEM fields, not only in Africa, even all over the world. So why does STEM matter? It matters because it helps drive innovation and progress. You know, these days is the world of, we're in the era of AI, isn't it? And if you go left, AI, go right, AI. It's a STEM field. And if you're not there, you might be left behind. So the gender gap we're talking about that we have seen in STEM, a lot of research has been done, a lot of statistics we can see that women make up less than 30% of the STEM workforce globally. Why is it so? We can see that in this. Because when I was just looking at this, you can see the STEM degrees and the gender gap. So why would there be less in the workforce? Because everybody wants to read a course that is a bit easy per se. Not that those courses are easy, but there have been that mentality in our homes. As a girl, you go and read sociology or psychology. You that is a banking and finance, my sister. You that is a boy, read mechanical engineering. You read computer science. You read, because you're a male. Nobody would ask you to go and read mechanical engineering as a female unless on your own you say, I want to do this course. I'm sure most of us that are here that read those courses were out of your own will. Because everybody around you will say, what are you going to do? Don't you know you're a woman? How will you climb there? What will you wear? Those are some of the social norms, some of the biases and lack of funding and all that give rise to this particular underrepresentation we are talking about. Now, look at this graph. Women make up of small percentage of STEM workers, as we have said. You can see the graph I have there. The ones on top are for the male, the one down are for the female. There's surely a slow, steady progress for female. You can see we're moving up. And the male, because our percentage is going up, the percentage of male in that particular workforce is coming down. Our aim, our desire is that one day, those two things will come together. We don't want to overtake yet. But we want a situation whereby those things come together. So that's so. But why do we see this? A lot of barriers. You can see this lady. A lot of things are holding her leg, her her waist, her hand, everywhere. Stereotype. STEM is for boys. Mentality is there. Lack of role models. Few women are out there that are visible. Even the ones that are making it, they want to hide themselves so that they will not say this one. There's an adage in my place that say, "Why cannot do this, do that." Immediately they say that, you know you have a place that is kept for you. You don't need to go there where the men are. So those are the mentalities we need to, remove. Educational gaps, limited access to STEM resources, which is one of the things we are clamoring for. If our partners will come and collaborate with us, workspace bias is there already. Gender discrimination, unequal opportunities. We mentioned it during the program that Professor Adeshope held. We said in this environment where we are being promoted yearly, or there are some rules that they need to look at the equity aspect of it. Give some leverage to women, because we stay 9 months pregnancy, then another 6 months maternity leave. Those things should be considered, because during those times you might not be able to even open any book, not to talk of doing any research, because you already have a greater research in your hand, So why do we need to be intentional about this thing? Why do we need to be intentional? It's very, very crucial. It is at the center of our heart, OWSD Uniform branch, that we affect these young ones to go into STEM fields, because look at the projection there. In 2031, STEM jobs are going to be the highest in the world. And if we're not there, we will be underrepresented the more. And some of us in IT, that those of us that build AI models, we have realized and we have seen that the data sets we collect that is real and correct make the bias to be more, because by the time you develop those tools and bring out these tools for people to use, the predictions will be according to what they learned from the data set, isn't it? And then things will keep going that side. So we are looking for a way to make these STEM fields more favorable for girl child, to increase these things and also close these gaps. So the benefits cannot be, we can't say it all. Breaking stereotype, unique perspective, economic empowerment, diversity drives and innovation. It drives innovation. I'm not saying that the other courses don't drive innovation, but we know that science, technology, engineering, maths is the thing that helps us in most of the breakthroughs we have in our research and in our environment. So I will not end this without talking about these inspiring Nigerian women in STEM. Fortunately, 2 of them are part of us. The first one is the first PhD computer science in Nigeria. Please clap for her. The second one is the beautiful Professor Ikerio Oluchi, who was the past president of this organization, who has done so well in her field of study. She's even now, presently, the Director of Academic Planning in the University of Harcourt. Please clap for her. Then we have another person that is so good in mentoring young ones. Her heart is so big. She can give and give, as long as it has to do with a girl child. Unfortunately, she has 3 girls and a boy, so she understands what we're saying. So she is Professor Choma Blaise Chikre, who is also a HOD of microbiology. So we are not saying what we don't know, because we have been there and we know it is very, very important to start at this stage to encourage these young girls. So what is the action? The action is collaboration is the key. For me, for us to be able to achieve these things, collaboration is the key. Anybody you know that is interested in making these things work in our little corners, We need to collaborate, we need to connect to be able to make this particular program a yearly thing. And I know the people I'm seeing here will talk to us very soon. Thank you. Together we can forge gender equality. So let's make every day International Women's Day, not only on 8th of March. Every day should be International Women's Day. It will affect how we think, it will affect what we do, it will affect everything pertaining to our activities. Do your bit to ensure that the future for girls is bright, equal, safe, and rewarding in your little corners, in your companies, collectively for International Women's Day. We can all accelerate that. Thank you so much.
Good afternoon, ladies and gentlemen. My name is Ukori Jordan, our Lady of Perpetual Documents. I'm here with ladies.
Judge Gabriela from Redeemers International Secondary School.
So today we'll be taking you on robotic programming and sensors. We all have heard about robotic and robots. What is robotic and robots? Robotics is a field of science and engineering that deals with the design, construction, and the application of robots. This means that robotics is a field in engineering, science, and technology that deals with the construction of robots to make human tasks easy or to perform human tasks. Robots are machines that have been made or created to automate tasks. Moving on, we have different types of robots. There are many different types of robots, but can be classified mainly in two categories, which are one, the industrial robots, and two, the service robots. The industrial robots are robots that are mainly used in factories to automate their works like welding, painting, and assembly. These robots are mainly used in industries. Now, service robots. Service robots are used in varieties of applications, such as in healthcare, customer service, and entertainment. These robots can perform different things. They can help in healthcare, they can help to entertain humans, and they can also help in customer service. There are different components of robots. There are different components of robots which are mainly four, which are one, the microcontroller, which consists of the Arduino UNO. Two, the sensor, which consists of the ultrasonic sensors. Three, the actuators, which consists of the servos and motors. And lastly, four, the body, which consists of the chassis and framework. The controller or the microcontroller is the brain of the robot. It tells robots what to do. Just as humans have brain, robots need brain to go to their work, because without the brain, they will not know what to do. They'll just like dummies moving up and down. Next, we have the actuators. The sensors, which enables the robot to see, hear, test, and even feel the world around it. These servos enables the robot to see with their sensors eyes or ultrasonic sensors, and also hear things, and also feel the world around it. Next, we have the actuators, which consists of the servos and motors. This enables the robot to move from one place to the other without, let me say, without hitting anything, like avoiding obstacles like what we have here. Next, lastly, we have the body, which consists of the framework and the chassis. This is the physical structure of the robot. It allows the robot, it is the framework of the robot. The chassis holds all the components of the robot together, and this body is made up of parts such as the frame, the arm, and the hand. Now, I would like to call on my colleague to talk about the components of an obstacle avoidance robot. Thanks.
Continuing from where my colleague saw, components of the robot. The first components used for an obstacle avoidance robot is the microcontroller. This is the microcontroller. It's also called the Arduino UNO. It's the brain of the robot. It receives information from the sensor and processes it. This is what makes the robot move and think. It also helps the robot in decision making. Then we also have the chassis. chassis. It is made up of purpose, which is strong and clear plastic. So it's a see-through chassis because you can see through it. And this makes the robot sturdy and lightweight. With this, the chassis, when all the components, you assemble all the components in it, which are the motors, the wheels, the sensors, and even the control board. We also have the ultrasonic sensor. This is your sensor. This ultrasonic sensor. It makes the robot see things far away without making use of a camera. The sensor sends out sound wave that makes it that you can't hear. That is what makes it ultrasonic, which means it's very high pitch and listens for echo. And it listens for echo. Then we also have the orbital motor. So this is our orbital motor. It's the motor of our robot. It consists of the stepped motor, the wheels, and the fixed motor. Our stepped motor makes your robot move in little steps. Our wheels are the round part that are connected to the motor. Then we also have the fixed motor. The fixed motor what holds the wheels in place. Then we also have our battery. This is our battery. Our battery is the power source of our robot. This is what gives energy to our robot. So without the battery, our robot cannot move or think. Then we also have our servo motor. Our servo motor turns 180 degrees when it detects an obstacle. Then we also have our jumper wire. These are our jumper wires. They are short insulated wires that connect 2 points on an electric circuit. This jumper wire connects components to the breadboard or connects to the microcontroller to its external devices. They are technically color coded to indicate their purpose of polarity. So like here, you can see the different colors of our jumper wires. The green stands for GND, the purple stands for tree, and the white stands for echo, and the purple stands for echo. Then we also have our dummy wheel. This is our dummy wheel. It's a non-functional wheel that is used for testing, demonstrating, and decorating purposes. It simulates the presence of wheel without actually rotating or producing a mechanical functionality. We also have our spacers. Our spacers are our mechanical components used in an assembling construction. They are used to separate our components from each other. They can be used for proper alignment, and they can also be used to reduce vibration during our coupling. We also have our USB cable. This is our USB cable. It's a connection that sends program from our computer to our board. It's also a power line because when codes are being inputted in it, the robot starts acting on the instruction that are being inputted. How robots work? Robots work by following a set of instructions. These instructions are called a program. The program tells the robot what to do step by step. The robot controller reads the program and tells the robot actuators what to do. The actuators then move the robot's body and the robot performs the desired task. So in this, our robot, when the program has been inputted on it, the robot does not need a human supervision to tell it what to do. It starts acting once the instruction has been given out. Then next we have our robot programming. The different programming languages for robots. There are many different programming languages that can be used for robots. Some popular programming languages for robots include Python, C++, and Java. Each programming language has its own strengths and weaknesses. These are students that did our practical. Then next we have assembling the robot. First, inside the fastener and the chassis. So this is our fastener that we inserted into our chassis, and we insert the encoder. This is your encoder. orbit gear motor that is being inserted into the chassis. Remember that the orbit gear motor consists of the stepped motor, the wheels, and the fixed motor. Then we fix the motor to the chassis, which I've already said. Then insert and tighten the screw. So this is the screws you insert it into the fastener to make sure your work is tight. Then you fix the dummy wheel into the chassis. This is your dummy wheel that is being fixed to the chassis. Then fix the servo motor and ultrasonic sensor. This is your sensor that is being fixed to the chassis. Then you fix the microcontroller to the robot. You fix your microcontroller to your robot because if you don't fix it, your robot can't work. Then you ensure all your connections are firm and then connect sensor, servo motor, and orbit gear motor with the microcontroller. So you make sure your spacers and your screws are well connected. Then how to program robots. To program a robot, you need to know the programming language that the robot uses. You also need to know the different components of the robot and how they work. Once you know these things, you can start writing programs for the robot. Programming the robot. Our robot here was programmed with the use of C++, which helps the robot to follow the instructions. So without these instructions, our robot can't move. In our robot here, once it's being turned on, you can see the robot moves forward, which is in the instruction. So if the instruction, when we made the instruction and we did the connections wrong, we see the robot moving backward. But because everything aligns, the robot is moving forward. Obstacle avoidance robot. An obstacle avoidance robot is a specialized autonomous robotic system designed to navigate through its environment while intelligently avoiding obstacles in its path. This technology finds diverse applications across various industries, including warehouse automation, agriculture, and surveillance. So when we say your robot is an obstacle avoidance robot and it's autonomous, it means that it can perfectly do a task without a human supervision. The aim of obstacle avoidance is to make the robot efficient, to increase productivity, and reduce cost of labor. Thank you for listening. I would also like to thank OWSD for giving us Mr. Peter and Ms. Claire from Robotics Engineering during our bootcamp. Thank you.